Imagine a sudden shift in the global technology balance, one so quiet that most of the world didn't notice it happening. While attention remained fixed on familiar industry giants, an unexpected transformation was taking place deep within China's technology sector. A fully operational artificial intelligence chip manufacturing facility has come online, one that functions entirely outside the reach of U.S. export restrictions. This plant is not just advanced. It represents a profound shift in how power, technology, and influence are distributed in the age of AI. What you're about to hear explains how Huawei fundamentally altered the rules of the semiconductor conflict and why a battle many believed was already decided has actually entered a new and far more complex phase. When U.S. authorities placed Huawei on the Entity List in 2019, the prevailing belief across the technology world was nearly unanimous. Analysts concluded that China's most prominent tech company had reached a dead end. Cut off from advanced chip-making tools, severed from partners like Nvidia and TSMC, and isolated from Western design ecosystems, Huawei appeared destined to fall behind permanently. The message from Washington was clear: comply with Western technology frameworks or accept irrelevance. But beneath the surface, something very different was unfolding. Instead of collapsing, Huawei began quietly transforming itself. A strategy was taking shape that did not depend on Silicon Valley approval or European licensing. Now, in 2025, the outcome of that transformation is visible. Huawei has brought online a fully functioning AI semiconductor production operation on Chinese soil, built on domestic engineering, supported by state-backed resources, and free from Western technology oversight. This facility contains no American components, no European monitoring systems, and no foreign intellectual property dependencies. According to industry observers, it is producing advanced AI processors using 7-nanometer fabrication processes, alongside custom neural processing units designed specifically for high-demand artificial intelligence workloads. These chips are being deployed for generative AI models, smart infrastructure, and large-scale computational systems. So how did Huawei manage this under some of the harshest technology sanctions ever imposed? The answer lies in ecosystem construction. Huawei recognized early that isolation would be fatal. Instead of standing alone, it built alliances. The company formed deep collaborative relationships with SMIC, China's most advanced domestic semiconductor manufacturer. Together, they established joint research and development operations that operated largely beyond international visibility. While Western policymakers focused on tightening enforcement mechanisms, Chinese engineers were rethinking chip design from first principles. Rather than chasing the absolute cutting edge of 3-nanometer fabrication that dominates Western headlines, Huawei chose a different path. The company focused on optimization, efficiency, and deployment practicality. Its processors are not intended to outperform Nvidia's flagship chips in raw benchmarks. Instead, they are engineered to deliver reliable performance in real-world environments, where power efficiency, heat control, and rapid integration matter more than peak theoretical output. These chips are now powering AI-driven robotics demonstrations, 5G base stations across China, autonomous vehicle testing environments, localized AI inference systems, and next-generation wireless infrastructure. They are also reportedly being evaluated for defense and security-related autonomous platforms. Crucially, these processors do not rely on SML's extreme ultraviolet lithography machines, nor do they require ARM licensing. This makes them genuinely sovereign technologies, developed for Chinese priorities and increasingly attractive to nations aligned with Beijing's strategic vision. Perhaps the most significant detail is scale. Industry sources indicate that the facility's production capacity can be expanded rapidly, potentially reaching around 2 million wafers per year by 2026. That volume would be sufficient to supply AI data centers, telecom networks, autonomous systems, and smart infrastructure, all without a single U.S.-sourced component. Huawei didn't merely survive sanctions. It adapted, evolved, and re-emerged as a serious contender in a technological competition many in Washington assumed was already settled. While Nvidia continues to dominate headlines with its H100 chips and upcoming Blackwell architecture, Huawei has pursued a quieter, more calculated approach. Instead of competing head-to-head on raw performance, it has chosen to redefine the battlefield entirely. At the core of this strategy is the Ascend AI processor family, which has reportedly undergone major upgrades, featuring a customized neural processing core internally known as Phoenix. Although official specifications remain closely guarded, leaked data suggests energy efficiency improvements of roughly 40% over previous Ascend generations. These chips integrate specialized tensor engines optimized for inference, distributed AI workloads, and real-time processing. This is more than an engineering achievement. It's a strategic declaration. Huawei is deliberately avoiding Nvidia's ecosystem dominance, particularly CUDA. Instead, it has built its own AI software environment centered on the MindSpore framework, supporting machine learning, computer vision, and natural language processing. Where Nvidia locks developers into a single proprietary platform, Huawei is building a parallel AI universe. Another key distinction is deployment flexibility. Nvidia's GPUs typically require centralized, power-hungry data centers. Huawei's processors, by contrast, are designed for distributed AI, ideal for smart cities, telecom networks, surveillance systems, and military-grade applications where low latency, energy efficiency, and sovereignty are critical. Most importantly, these chips are already in use. According to Chinese government documentation, early production models are operating in hundreds of pilot projects nationwide, including automated ports, intelligent traffic systems, and industrial AI platforms. This is not experimental technology. It's live, functioning infrastructure. This poses a direct challenge to Nvidia. Huawei's chips may not dominate benchmark charts, but they are faster to deploy, cheaper to produce, and immune to export restrictions. That combination creates an advantage Nvidia cannot easily replicate. For investors betting on Nvidia's unlimited global expansion, this development is a warning sign. Huawei is building a parallel, a semiconductor market, one that operates independently of U.S. supply chains, the dollar-based financial system, and Western regulatory control. This is the chip architecture of a multipolar world. For decades, the semiconductor industry revolved around a small group of Western and allied companies. Cutting-edge chips required Western tools, Western software, and Western approval. Huawei's new AI manufacturing capability demonstrates that this assumption no longer universally applies. China is not just supporting one company, it is restructuring its entire technology ecosystem. Huawei's facility is only one node in a fully domestic, vertically integrated supply chain. From raw materials to fabrication, packaging, testing, and deployment, the entire process now occurs within China's borders. This level of self-sufficiency is the result of systematic substitution. Over the past 5 years, China has recreated each link in the semiconductor value chain using domestic alternatives. Electronic design automation tools have been replaced with indigenous software. Deep ultraviolet lithography has been optimized through software compensation. SMIC has scaled 7-nanometer production and is experimenting with even smaller nodes. Packaging and testing are handled by domestic firms, while servers and storage rely on Huawei's own CPUs and systems. What once required global cooperation now functions as a national technology alliance supported by massive state investment. The implications are global. Nvidia once derived a significant share of its data center revenue from China. That market is now shrinking rapidly, and the impact doesn't stop there. Countries aligned with Beijing are increasingly viewing Huawei's chips as geopolitically safe alternatives. Meanwhile, the United States is attempting to rebuild its semiconductor base through reshoring initiatives. billions have been allocated. New fabs are under construction, but delays, workforce shortages, and supply chain complexity persist. Huawei's facility, by contrast, is already producing at scale. As the world fragments into competing technology blocks, the rules of competition are changing. The semiconductor race is no longer just about who has the fastest chip. It's about who can build resilient, independent systems that function under geopolitical pressure. The chip war is not ending. It's evolving. The real question now is whether the United States is prepared for a future where it no longer controls the gateways to technological advancement. Huawei didn't just build a factory. It built an alternative future, one that Western policymakers can neither easily regulate nor fully contain. The rules have changed. The center of gravity is shifting, and the next phase of global technology competition has already begun.